Anyone wants to make a guess as to what this person is waiting for? So he just had a production issue. Unfortunately, the logs which he needed to investigate were not there. So he just enabled extra detailed logging, but now he's waiting for the issue to reproduce. How many of you can relate to this thing where you just enable logs, now you need to wait? So today, we'll be talking about how to fix this issue. Welcome to the talk on high volume logging without the high cost, or what I call as flight recorder for OpenTelemetry logs. Hi everyone, I'm Cijo. I work as a software engineer for Microsoft, focusing on observability. I've been part of OpenTelemetry from almost the very beginning itself. I've been the maintainer for OpenTelemetry.net, and I'm also a maintainer for OpenTelemetry Rust. I also help a bit on the specification side in my role as specification sponsor. So let's get started. So let's talk about what is the motivation behind this whole talk. The cost for telemetry is becoming a huge concern for all organizations. In particular, logs dominate the telemetry costs. And developers who write instrumentation, they generally try to do like extra liberal with the logs because they don't want to be in a situation where they're hitting an issue in production, they don't have the logs, so they just try to instrument liberally just in case. Just in case something goes wrong, they want the logs. So just instrument liberally out of FOMO, like fear of missing out. But most of these logs, they don't really have any value unless something bad occurs. So especially with the agentic application, the amount of logs being produced are like crazy. All the agent interaction with LLMs, the input, output, they're all like dumped into the logging system, but they're not usually useful unless something failed. So what do people do to avoid the cost of these logs? Solutions often include like disabling detailed logs altogether. A quite common configuration in production, you only enable warning and error, or just error, and other logs are just disabled. Or people try to assign some score or value to each log, and they filter it out. If they deem that this log is not that useful, they just drop it. But the problem is, when the issue occurs, you have to now go and enable it, and we'll be back to where I started. We know how to wait for the issue to reproduce. So the reason why these solutions are not very good is they determine the value of a log based on the log content itself. But most often, the value of a log comes from the broader context which it is part of. For example, if you're doing some logging as part of a transaction, and the transaction failed, now, all the logs which you emitted, including the info, potentially verbose and debug logs, they are golden. But if the transaction succeeds, then they are just noise. They're just eating up your telemetry bill and nothing else. So if you just keep exporting everything, you will have to pay a huge bill for your telemetry. But if you try to filter things, then you have blind spots. Let's see, can we do better? So that's the topic today. It's called flight recorder pattern. Full disclosure, there is nothing new or innovative or nothing revolutionary here. It's just things like copying or learning from other systems into OpenTelemetry. The idea is very simple. Instead of streaming or sending logs all the time to your backend, you keep that in a ring buffer or a circular buffer, constantly overriding the older ones as the new one comes in. And if an issue occurs, which I call as a trigger, like there is a bad event coming or some live site is occurring, that could be the trigger. And in the case of a trigger, you snap the buffer. So whatever you are accumulating in the buffer, you snap it and export using OTLP or whatever mechanisms you were doing. And as soon as a trigger is done, along with the snapshot, you also enter a temporary streaming mode so that like any logs after the fact can also be captured. And after that temporary period, you go back to the circular mode. This is a very simple idea. Again, like nothing very new to software. It's been there in many, many places. So we'll talk about where and how to implement such a pattern. There are 3 places which I'll be covering. There could be more, starting with at your application or in a collector or in an operating system kernel facility. We'll cover them one by one. First one is at the application level. So it could be your logging library itself, or it could be a custom plugin to a logging library, or it could be implemented using OpenTelemetry log record processors where you can keep things in buffer. Like sometimes people have like developed custom conventions of their own, where in your application code, they just accumulate logs in their own custom memory, and they only call the logger method or log method if something goes wrong. So there are like so many places where this can be implemented, so many different ways this can be implemented at the application. I'm going to use like one example and do a quick demo just to make sure like everyone gets the concept. So I'm going to use .NET as an example. So .NET's iLogger, which is the logging library for .NET, has recently, as in very recently, introduced a concept called log buffering. They didn't call it flight recorder because it was just my name. So we'll see like how it goes. So I have a web application which is quite simple. All it does is it responds to a hello request. And while doing that, it generates a dozen of logs. If you look at it, almost all of them are like info level logs, except one warning log. So I'm going to run the application. Oops. Yeah. So the app is running, and I'm going to make a request to the application to the hello endpoint. Okay. Yeah. So you can see I'm making like another request, keeping on making requests. So you're only seeing like that one warning log came out, even though I had like dozens of info log. So what happened to those log? So they are kept in the ring buffer, waiting for a trigger to occur. So in my case, I have programmatically decided like what is my trigger. So my trigger is if the failure, in this case for demo purposes, all I need is to pass a fail equal to false as a query string to trigger the failure. And if the failure occurs, it's going to call buffer.flush. We'll see what that does. So I'm going to fire another request. As you can see, just one. Now I'm going to trigger a failure. So let me fire a. So now what happened is, I'm going to get all the info logs, about a dozen of them for that request. And not just that, it actually kept all the logs from the beginning. In fact, whatever was the buffer size, all the logs which it could fit in that buffer is now exposed right now. So you can see not only the log from the sixth request, it just have a request count just to keep it easy to track. It has logs from the previous one, all the way until the buffer ran out. And if I make another request, the normal request, you can see it's now producing not just a warning, it's producing the entire log. This is what I was mentioning in the beginning, that once it enters, or once a trigger is done, for the next few seconds, it's going to stream all the logs. So I have set it up so that for the next 30 seconds, it's going to stream everything. But now that 30 seconds has evaporated, so it's going back to the original mode where only warning is coming up. And the configuration is very straightforward. It's just 3-4 lines of code to get something like this in .NET. This is only in the latest version of .NET. So here, your configuration is how much buffer you want to allocate. So 100 MB is the ring buffer size, and this is 45 seconds. So after you trigger a flush, for 45 seconds, it does the continuous streaming instead of buffering. And you can determine like which logs goes to this path versus the normal path. So in this case, I have set it in such a way that all info logs takes the flight recorder path, and all other logs, in my case, like warning or above, they just go the normal way. So this is just to demonstrate like what is conceptually mean by like flight recorder. As I mentioned, it's not like a completely new thing. It's not a new thing. It's been there for like in various shapes in various systems. So this is one example of how to do that using .NET iLogger. So back to like we were trying to figure out like where to do this. So this is doing it as application level. The benefit for this one is it's very simple and it's very efficient. Efficient in the sense the logs never leave your application. So there is no disk, no network, no cost at all, except you pay for a bit of extra memory to keep the logs in buffer. But what are the downsides for this approach? The first downside is, if your app crashes, you would lose all the logs. For example, you were accumulating logs in your memory, and you wait for a bad event to occur to trigger it, but that bad event or that bad thing could be so fatal that it could take down your entire application, taking the logs with it. So even though logs being in the application's memory, it's like very simple, it has this huge downside where you would lose visibility if your app itself crashes. And also, you're relying on the app to behave properly to flush when it is supposed to flush. So if your app goes rogue, like completely out of your control, like stuck in a deadlock, not making progress, then it won't do its job when it is supposed to flush. And also, this is not a universal solution. So what I showed was .NET's iLogger, which just came out like 4 months ago. I don't think there are many logging libraries which has this solution. So if at all you want to do this, you are mostly going to like craft something by hand. And this won't be universal. It will be like following its own rule. Very recently, Go has introduced something like this. They actually call it Go Flight Recorder in 1.25. It does the same thing. It keeps things in a ring buffer, and if things, depending on some criteria, it starts flushing. But even that is only for like Go runtime events, not for application events. The point is, there is no universal way of doing this in application. So you are completely on your own to build something on your own. Let's see where else we can do it. The next option is we can do that in the collector. So instead of keeping the logs in the application's memory, we ship it to a collector or collectors, depending on your overall architecture. It works very similar to a tail-based sampling, which is already there for tracing. And you know it's not super straightforward to get something like that done, because in the case of traces, you need a good load balancer at the L7 to route traces to the right collector, which has all the traces, all the spans for that trace. Similar challenges will exist if you were to do it for logs also. And additionally, now you're not storing logs in memory of your application anymore. You're shipping it to a collector or combination of collectors. That means you have to eat the network cost. And this is still susceptible to collector crashing. So at least you are now safe from your app crashing, but now you're still not safe in case your collector crashes because it's holding the buffer. So what is preventing us from doing a proper flight recorder in OpenTelemetry? What are the missing ingredients? So we really need something local so that you don't need to touch network. We need something very high performant because now we are talking about potentially enabling very detailed logs. So it has to be like very performant and it has to be reliable, extremely reliable, because even if your app or the collector or the listener is like both of them are down or either of them are down, you still want the logs to be reliably collected. So you need like some solution which can be like local, highly performant, highly reliable. And bonus, if that can natively understand the concept of a trigger and snapshot. The good news is operating systems already have these mechanisms baked into it. So Windows, it's called event tracing for Windows, or ETW for short. In Linux, it's called Linux Tracepoints. Both are like at least 10 to 15-year-old technology. Recently, like Microsoft contributed something to Linux kernel called user events, which basically is allowing user mode applications to write events to Linux Tracepoints. So previously it was restricted to kernel mode events, but now it can be done from user mode applications, aka OpenTelemetry. How this is going to work? So instead of shipping logs using OTLP, we would ship the logs using either like in Windows ETW or Linux Tracepoint. And these are built-in flight recorders. You don't need to invent a circular buffer. These systems have like a built-in ring buffer capable of holding logs in the circular fashion as we described. And they both have, in both Windows and Linux, they have a notion of trigger and snapshot. So it can understand like what is meant by trigger. You don't need to programmatically do something. You just need to tell what are your triggers. And it has a first-class concept of snapshot where a buffer can be snapshotted to a different place, and from there it can be shipped via OTLP. How we are going to do this? Let's look at this picture where I'm comparing the exporting via OTLP versus exporting via the operating system native techniques. So on the top is the typical application, which is instrumented with OTel SDK, paired with an OTLP exporter, sending continuously to a collector. There could be more collectors, but for simplicity, that's a structure. And bottom, I have shown a same app, same structure, except instead of exporting via OTLP, we are now exporting you using operating system native technique. Now, those exporters send telemetry to the kernel, and the kernel stores that, or the kernel's tracing facility stores them in a kernel-backed ring buffers. It may appear as if they are disks or storage devices, but they're not. The kernel buffer is completely in memory. There is no disk involved. Unfortunately, the picture might give the impression of a disk, but it is just like a memory. So telemetry is kept in that kernel buffer, and whoever is the listener, so a collector could be the listener, so it can instruct or it can configure the tracing system, hey, let me know when there are events, I'll just snap it. Or you can configure it so that it tells the kernel, keep it until the trigger occurs, and if the trigger occurs, give it to me. Otherwise, keep it and continuously overwrite it. So that's how it looks like. I'll also show a like little bit of pseudo code just to show how the code would look like if you were to implement this. On the left-hand side is the OTLP, and on the right-hand side is the OS native. So the idea in OTLP is you don't export like every log at a time. You can probably never afford to do that because it involves like gRPC or HTTP. So what you do is, I mean, irrespective of what you do in your logging, ultimately it boils down to a emit log method which has a log record in it. So what you typically do is you queue it up into a in-memory buffer or like to do like some sort of batching, and there is a background thread which wakes up every second or a few seconds and takes whatever you have accumulated and then ships it to OTLP. On the other hand, the way ETW or user-driven exporting works, it's a completely different paradigm. It's very, very different. I have tried to simplify it with a simple pseudocode. So it works in a synchronous fashion. So that in the emit log method, you have the log record. So there is no batching, there is no buffering. It takes the log and hands it over to the kernel synchronously. So it's a very different paradigm. There is no queuing, there is no batching, it's written synchronously. Now we'll see why this is relevant in a moment. So by the time the log method is done, you are assured that the log is now backed by the kernel buffer. So you can afford to crash at that point. You're not going to lose anything, which is very different in OTLP because if you crash right after you emit a log, all the things in buffer is gone. So what are the advantages? Like why we can implement, like even though we mentioned like there are many places to implement a flight recorder for OTel, why is it beneficial to you use native OS tracing facility to do this? The one thing is it's a proven foundation. These techniques are at least a decade old, like ETW and Tracepoints has been there for more than 10 years, and they have been like proving very useful already. So it's a solid foundation. We're not having to build something from scratch. On top of that, it's managed outside your application. So it's extremely reliable in the sense I mentioned, like your app goes down, you're not losing anything because the memory is backed by the kernel itself. Also, even if your collector goes down, like for example, you are like collecting using collector and collector had a crash, it came back like 10 seconds later. So what would happen to the logs from that 10 seconds? Depending on whether your exporters had retry or not, you may get some of them or you may not. But in case of OS native, even if the listener is down, the kernel can still keep track of the events in its memory. Of course, there are limits to the memory. So as long as your memory is not overrunning, you wouldn't lose the telemetry even in the event of collector crashing. Another advantage is, so once you try to operationalize this thing, this is like very good to hear, but once you try to operationalize this thing, one of the biggest challenges is how much memory I should allocate, how much memory I can keep for my ring buffer. So if you do like a 1 GB memory, you can probably hold around 1 million logs. So depending on your application's load, it could last like several hours of telemetry, or if it's a high volume log, then it may only last for a few minutes. So you'll have to constantly tune like what goes into the to the buffer. And sometimes, it's not sometimes, very often you would not know what logs are valuable even though you're like recording it in circular. It's common that you would find that some logs dominate, they just take up the entire buffer compared to some other logs. Effectively means like you will be like just collecting like few subset of logs because they just override the previous one. So what if you realize that one log is just like too noisy and it's not that useful? So you can go back to your application and re-instrument to not emit that log. Or in case of OS native tracing, they have a built-in functionality called is-enabled check. So before every log is emitted, you can ask the kernel, hey, is there a listener for this event? And you can modify the listener so that I'm not interested in this log anymore. So it will start dropping it on the floor without having to touch your application. So this is completely controlled externally. And if people who follow OpenTelemetry, there is a recent addition to OpenTelemetry logs where we introduced something called logger.enable, which basically checks the your exporter or processor, hey, is there any interested party for this event? And by hooking ETW or user event exporter to that, we can pretty much achieve the goal of like turning on and off a log externally, even without touching your application. So even when you do flight recorder, you may hit the issue of the too much of a noisy log dominating your overall space. So you can avoid that, or you can, even if you hit that, you can just turn off that log to get back. Lastly, this is actually very important because now we are talking about potentially doing much more logs from your application. It may get dropped elsewhere, but from your application standpoint, you're always emitting it. So it has to be very performant in order for you to do it. And the OS native exporters are extremely performant. I'll tell like 2 reasons why they are fast. Number 1, I already explained, it's a synchronous exporting, which means you can afford to do the logging with stack only, because there is no buffering. There is nothing you need to store beyond the function call itself, which means you can afford to do the logging with simple stack, no heap at all, which is already a very good thing, because most people who worked in logging libraries, one of the biggest goal which people try to achieve is, can I do logging without heap allocation? And we have, it's quite possible if you are exporting to the OS native system. Based on our benchmarks, I implemented this for like many languages, but for OpenTelemetry Rust, our logging is the entire act of logging, like taking the log, sending it to OpenTelemetry, feeding it to the kernel, making the syscall and back. It's around 500 nanoseconds. That's like half a microsecond. It's extremely fast, so that you can afford to send more and more logs. And number 2 is the buffers to which the logs are written. They are per CPU buffer. Both in Windows and Linux, the tracing facility keeps per CPU buffer. So let's say you are operating a like 10-core machine and you have 10 threads, all trying to write logs. They can do it like truly parallel. Like there is no contention, there is no lock or mutex or anything. They occur like truly in parallel, which means if you increase the number of CPU, your application can scale very nicely without any bottleneck. I have some numbers at the end where it shows like if you increase the number of cores, you increase your throughput like almost linearly. It's like, it's something like what we call as shared nothing architecture. There is nothing being shared between 2 threads. They truly operate in parallel without any global state. So this gives like a lot of advantages when you leverage the kernel buffer to achieve flight recorder pattern. Let's also talk about what is the current state of things. So we have exporters in 3 languages in OpenTelemetry to ETW and user events. It's in the contrib repo. Unfortunately, the collector does not have a receiver to accept these events. So in my company, we use a proprietary agent to do this. So as of now, we don't have anything in the collector to understand ETW or user events. It's an opportunity. Maybe in the next time, like next year, we would have improved the situation so that like collector will natively understand this thing and we can implement a full flight recorder, leveraging the OS facility, still using the collector. We have started a Slack channel a few months ago. There are a lot of interesting discussions there. So if you have interest in contributing or sharing feedback or sharing ideas, feel free to reach out. You can either reach out to me or use the CNCF OTel Dynamic Telemetry Slack channel. Key takeaways. So we discussed like logs are like the value of a log is usually lies with the context. It cannot be determined whether a log is useful by just looking at that log. So if something goes bad, OTel is very good at detecting that, but what can explain is the logs which happened before that. So with flight recorder, you never have to worry about losing the important logs when you need it, because you always buffer it, but you never export it. So you don't pay the cost of telemetry unless something goes wrong. And this can greatly reduce your observability bill. And if you can build it on top of the proven OS technology, you'll gain all the benefits like high performance and the like high reliability, like not even susceptible to app crashes, things like that. I think that's pretty much the topic. I have put the references here. All the like exporters and things are mentioned here. So we want to like go ahead and take a look at this thing. Okay, thank you. And since I have a minute left, I can take any questions. If not, I'll be available outside, or you can reach out to me in Slack. Thank you.